Today we're going to see how to power and wire 16 servo motors for Arduino using the PCA9685 PWM driver. I'm going to be using 5 volt power, so the first thing I want to do is show you how I decide which power supply to use. Let's get started. I don't have 16 of the same servo motors, so today we're going to use 4 of the small SG90 servos. We're going to use some MG995 servos, and then some Miyuzi 996, which is basically a clone of the MG996. There aren't any fundamental discrepancies when using these 3 different servo motors with the same PCA9685 board, but you also want to take a couple things into account. And one of those things is PWM frequency. Most of these hobby servos are going to operate at 50 Hz, and all 3 of these do. You also want to consider the pulse width range calibration. And the typical pulse width for these hobby servos is approximately 500 to 2500 microseconds. So keep in mind, even if they share voltage and frequency, if you're mixing your servos like we are here today, they may have different torque, speed, and precision characteristics, and that could show up in performance differences in your project. Maybe you can't find the data sheet, or you just want to see for yourself just an estimate of the current that this thing draws when it's moving. It's at 5 volt, no load. So let's go ahead and take a look. I've connected it to a desktop power supply, and it's running at 4.9 volts, 4.99. I'm going to turn that up a little bit to 5. Not that it matters, but you can see that it goes up to about 300 milliamp when it turns, and then resting is about 12 at 5 volt. And of course, if you turn that up, it'll obviously draw more current. Go ahead and turn it up to 6.07. And you can see it draws a little more current. It's in the 400s, 460, something like that. And you can definitely tell that it sounds a little bit different. It feels like it's working a lot harder. So it's going to draw more current, but that's just it's not an analytical exact value, but it is just a rough estimate of what one will draw when it's just connected to a board with no load. While this may be okay with small projects, you may want a more precise reading with a multimeter. We can connect the ground pin and a signal pin to the Arduino and insert the multimeter in series with the servo so that all the current flows through the meter. We'll do this by connecting the ground rail of the breadboard to both the servo motor and the Arduino, and the signal pin of the servo motor to Arduino pin number 9 for me. And I'll connect the COM port of the multimeter to the power pin of the servo motor and the A port of the multimeter to the 5 volt rail of the breadboard. And you can see I get anywhere from 129 milliamps to 279 milliamps. Now if I have 16 servo motors just like this, if I multiply this current by 16, it would give me a safe upper bound if every motor were to draw the maximum current simultaneously. However, in many practical situations, you might not need a power supply for exactly the worst case scenario, especially if all the motors won't be under full load at the same time. You'll see here in this project that all the wires connected to the lever connectors are all power pins to the servo motors, and all the servo motors are powered by an external power supply. To determine which power supply I need, I'm going to multiply 600 because that's the largest current value that I measured. Multiply that by 16, the number of servos, and that gives me 9,600 milliamps that I need for my project. And I always add 20% on top of what I need just for overhead so things don't heat up, so that's an extra 2,000 milliamps. So in this case, a 5 volt 15 amp power supply would be more than sufficient. For the wiring, I have the Arduino and the PCA9685 board controlling the signal for the servos. All the servos are powered by the external power supply. Here's a look at the diagram with just 4 servo motors. I wanted to keep it at 4 so that I didn't overcrowd the image. Here are all the ground connections for this project, and they are connected to a terminal block along with negative power supply. You also want to make sure your wires are sized appropriately for the current that they are expected to carry. You may also want to consider some capacitors at the power source to help with voltage stability. I connected the PCA9685 board to Arduino using I2C pins, SDA and SCL, connect the VCC to 5 volt and ground to ground. I connected 5 volt from the power supply directly to a lever terminal and then distributed that to 4 other lever terminals where they were connected to the servo motors. And here I made them actually just do a bunch of random movements. Now the other pins from the servo motor, when I connected those to the PCA9685 board, I just used the PWM pin and the ground pin. I did not use the V plus pin because we're powering our servo motors using external power. So I didn't use any of the V plus pins on this board, and the only reason I would use this side of the board is if I was to expand to another PCA9685 board. So here's one last look at my diagram, and of course you would add more servos the same way I did these four right here. And here's a look at my setup. This is actually a power supply that I use for LEDs. It is a variable power supply, 20 volt, 20 amp. And the length of the wire and the gauge of the wire will have an effect on power supplies. So keep that in mind. You don't want some really long wire. The shorter the better. And you want the correct gauge so that it doesn't get hot and overheat. That's about it. It's pretty simple. This is how I set up my project if it requires more than 10 amps. You shouldn't put 10 amps, more than 10 amps through this PCA9685 board. So I hope this was helpful. So this is how I do it. I'm sure there are other ways to do this, and probably better ways. If you know of a better way, go ahead and leave it in a comment. I'd be interested to hear about it. You definitely want to do your own research before setting up something like this to make sure you're getting the best for your project. You don't want to just blindly put this stuff together, so be careful when working with high current as well. Well, that's all I've got for you today. I hope you liked the video. If you found it useful, be sure to like the video by clicking the thumbs up. Also share it with anybody else who may find it useful, and I'll see you again with another project.